Thank you all for coming.
Sure.
Appreciate it. Just to give everyone a perspective, let's start with talking about who you are and what you do. So,
I'm Vlado. I'm one of the creators of V-Ray. I'm not the V-Ray guy because there are a lot more people working on that now.
You are known as the voice of V-Ray, though.
Voice of V-Ray, that's good. Yes. We've been trying to do lots of stuff with GPUs over the last few years, and the last year in particular was very interesting because we did a lot of work with Mike and with Kevin to get some interesting stuff.
I'm Mike Romy. I'm the head of the pipeline at Zoic Studios. And some of the things that I do at Zoic is kind of make sure that our workflow and our processes go as smoothly as possible, whether it be simple things like time cards and actualizing, but also rendering, as well as our virtual production arm called Zeus. And so that's where we got involved with V-Ray.
Kevin Margot, I'm a VFX CG supervisor at Blur Studio, also an independent director and filmmaker. I love V-Ray, and I've always been looking for ways to harness it to enable me to create art and as a form of expression and create my own films.
Mike, you'd be a perfect person to describe the pipeline. What is a traditional CG pipeline?
Typical pipeline is kind of made up of three components: pre-production, production, and post-production.
Okay.
And so generally speaking, visual effects gets involved in the back end, the post-production.
Coming from an angle of an entirely CG perspective, the concept of pre-production, when the end result is all CG, you're doing concepts, storyboards, layout, previs in CG. The production aspect itself is also, fully CG, modeling characters, environments, all the effects work and everything, animation rigging. It's almost like post-production at the same time.
From your perspective, why is lighting normally happen at the end?
When you're going to commit to relying on that kind of hardware, you want to be in a position where you're not going to have to redo a lot just because animation has been updated or cameras have been adjusted. Okay. Both in terms of hardware costs, but also because of artist efficiency.
When the GPU got introduced, the GPU basically pushed that ceiling up. I remember the presentation that was given a long time ago, and basically Vlado showed us a demo where it was 20 times faster. How is it that you can get a GPU to actually render what you're doing?
Even when they were doing traditional OpenGL graphics DirectX, they were designed to be massively parallel. So because they have to put pixels on the screen, it made a lot of sense to do many pixels in parallel. And then the same concept was extended to general calculations, where you take a bunch of calculations that are very similar and you multiply them across many processors and many threads. And it's not on the CPU you get 8 cores, which is maybe like 16 threads running in parallel. On the GPU you have thousands of threads running in parallel. So it's a massively different architecture. Okay.
This triad perspective where you have performance, you have price, and then you have the memory footprint, the actual requirements. And I think what we're seeing now is a point at which the scales are tipping, where you can get the quality. In the case of V-Ray RT, we're able to get the quality and our expectations for final frame rendering. Out of it, we can see the vision of being able to put our assets into that memory footprint. The price and the performance can scale at a point in which it's actually more beneficial to be in the GPU than it is in the CPU.
You were starting this new project with NVIDIA and Chaos Group. What's the name of the project you were?
So it's called the Lighthouse Project. And really, the purpose of this project was to find a way to actually use our production workflow to deliver final frame rendering. One of the shows we work on is Once Upon a Time for ABC. The show is basically all shot virtually. So they do 6-7 days of green screen. They shoot through pages and pages of script at a day. At the end of a production, they do the edit and they come back to us and say, okay, we have 800 shots that go on air in 15, 16 days. What we'll find is that we have multiple shows like this delivering at the same time, overlapping, and we can't possibly scale our render farm to the size to meet those short-term demands. Right. So we're trying to find, well, instead of us trying to find a way to rent more machines or buy more machines or send it to the cloud, yada, 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 maybe there's a way that we can actually just reduce the size of the wall and get what we want faster, and that's where we think the GPU will go. For this project, we did some analysis, and we basically took an asset and said, oh, how long does this one asset take to render? If we had to render all the render layers that we typically render and all the passes that we needed to render. We came up to basically roughly an hour and a half of what we were spending on a single frame of a CPU. We broke that down to the GPU, working with V-Ray and Vlado, and we basically were able to get a comparable, if not better in many cases, render times and quality at 15 minutes a frame. Okay. The challenge is just making sure pixel for pixel we have match in terms of the rendered final beauty result.
Okay. And the main reason that's been a challenge is that because it doesn't render the same, or is it because that it's mainly there's some features that are missing?
I think it's features. I think we're at the point where people haven't identified and prioritized to developers that this is possible.
The one thing that became very apparent is that we didn't support enough shading nodes. Procedural textures, mostly, we didn't have that. And we had to work on this. And one of them, the ramp shader, was actually everywhere.
Basically, every time you'd add a little feature,
yes,
something would happen.
So it was very obvious that we have to solve this problem somehow first, because if we eventually, when we add all the features, we might end up with something that's really not usable.
Okay.
One of our developers, Blago, looked into that and found that there's actually a way to, instead of compiling directly to GPU code, we could compile to a PTX. So we would look at what kind of materials are in the scene, what kind of lights, and just strip away code that we don't need for that scene. And then we would give it to the GPU driver to recompile it.
Right.
And this actually seemed to work pretty well. It gave us back all the performance that we lost adding those features. So now we can go on and do all the rest of the stuff that we need to.
Instead of actually trying to add features, while you're adding features, your code is stripping away features that are not necessary.
Yeah.
So we've come to the position where basically you needed to get through production a lot faster because of the huge demands on your facility. And you got introduced in a completely different way.
I reached out to a team of artists, friends that I work with, super talented people, and I said, you know, there's a short film that I want to do. I want to try and render it all on GPU.
What happens when you take that kind of hardware and you take the software that takes advantage of that hardware and you give it to, you know, the Tonys and Alessandros and those guys?
Well, you get the same quality that all these people have been delivering and posting on the internet, but faster. We were doing Skype sessions where I was watching them manipulate Max sessions with V-Ray RT running, and I was able to, like, you know, add suggestions, critique lighting.
Oh, right.
Yeah, while we were Skyping.
Traditionally, in an all-CG spot like Construct, the production phase is what we would call the animation phase, right? You have access to a motion capture studio, right? Tell us the idea you had in terms of trying to integrate rendering in that production phase of things.
I had seen a lot of great advancements with V-Ray RT and all this recent GPU power.
Right.
So, you know, I approached you guys and, like, you know, okay, well, we'll do this short film, let's do this, but then let's try and develop this RT for Motion Builder.
We already had something called V-Ray App SDK, which is sort of like a wrapper around the V-Ray API. It's something that allows you to really quickly build an RT application. Nicola is the developer who worked on this, and he spent quite a bit of time with Motion Builder doing a small prototype in Python, and surprisingly it worked.
So Motion Builder basically ingests all this data of performers moving around inside this volume stage, and then Motion Builder basically has a, you know, rig of these characters in which you're, you know, applying the data, and then you can up until this point, you could have an OpenGL viewport in which you were seeing these characters run around.
Right, so Motion Builder is basically the software that ingests the data and translates that to animation in some
Yes.
kind. And so before, like you were saying, you could only see the not so great video game version of them. What are you doing with V-Ray now?
We are running V-Ray atop Motion Builder with all this beautiful lighting and shading in real time, and then delivering that to a viewport or a virtual camera in the set as well.
So you're telling me that basically what you're seeing inside of Motion Builder is the same thing, essentially, that you'll be seeing for the final frame. With the actual lighting that you're rendering, you're seeing with the actual shaders. So you've been on Skype, you saw the shaders, they can take those same shaders and apply them right there while they're animating.
Yes.
Tell me some of the potential of what's going on.
All these real-world camera parameters are now, we can now start to translate into this virtual production environment. All the real-world lighting settings we can start to introduce into this virtual production environment. and then throw into that all these naturalistic looking shaders that V-Ray RT provides, you can really start to think about lighting and camera art direction at the same time you're doing performance capture. You can replicate the live action workflow much more closely now. Getting input and insight from all the experience accumulated over decades from the live action world. You know, it's like I'm starting to talk with cinematographers now. I'm like, look at this. What do you think about this? And they're like, this is amazing. Being able to control and manipulate and influence the end product using the existing skill set that me and the visual effects community has. If we are the ones that are able to establish lighting and camera decisions in a context that we are familiar with, a virtual production, that has huge implications onto how films could be made in the future. If we are able to establish with high fidelity, thanks to like V-Ray RT and these photorealistic shaders, if we can establish sets that look natural and photoreal, that is informing how the live action set could be built, and then how the live action DPs could be lighting their live action characters.
This DP, who's probably feeling that a lot of these decisions are being taken away from him because of the CG, could be empowered by the technology to start. As
effects artists, we become lobbyists. We're lobbying between the communication.
Yeah,
between
suddenly you're giving this power back to the DP. It's like, here you go. Here is your light kit. Here is what you want to do. You go in there, light it the way you want it, and it'll happen live for you. And you can make that decision right now. And wouldn't it be great to leverage all that knowledge that the DP already has? Darren's reaction, seeing his reaction to seeing his virtual self lit was quite interesting.
You take this, you look at yourself in the mirror. So what's going on now is I put up a mirror in this environment, and now Darren, as Bill, is gonna go up and look in the mirror at himself. Let's see this. Pause.
Pausing.
Play.
Playing.
Woo!
If you can enable them to see the end result in real time or after the take or whatever, that is going to inform how they might, move the character or perform.
Traditionally speaking, V-Ray was being used by your look development artist and also used by your lighter, right? Now suddenly you're going to give V-Ray to your animator, to your motion capture studio, to previs, to texture artists. They can be painting live and seeing the renderings affected in real time.
It's an invisible part of the process. It's always going, it's always there.
Now that you're just basically just getting these super fast stuff, you're not worrying about render settings as much.
No. There's an elegance to like the concept of like path tracing, and it's just like so simple, like the way it's going to generate this amazing image.
Right. I think that based on everything I've just seen, that you guys have taken a lot of advantage of it, and Vlado's been able to come up with a lot of interesting solutions to the problem. So it's been a creative process on all fronts, including the development part of things. We're kind of pioneering some of this workflow right now. So we also have a little bit of a responsibility here in terms of that process.
I don't think of like creativity as being like something that is reserved for only a few people. And if we can democratize the creative process as much as possible and enable as many people that want to like create, to do such, and in as efficient, fast, fluid way as possible, like let's do that. Because I mean, out of that can come an amazingly broad set of ideas and creative impulses.
Right. Cool. And Vlad, what do you think about this?
I have to make it all work.